What's up mga ka-ChE? It's Kuya here and I am back with another chemical engineering lesson. So we're now moving to fluid mechanics, which is the next part in our series. So I am still using this reviewer for chemical engineering licensure examination by MRII. So this is their compiled questions from the old board exam, and this is not sponsored by them. They just give me permission, and part of that agreement was to endorse their book. That actually you can buy this sa National Bookstore and also sa Shopee or Lazada. Okay, so yan. So I'm now moving to fluid mechanics, which is uh, an important part of chemical engineering and also in civil engineering, because it is the part where we measure the velocity of fluids, diba? And it is also important for us to learn this, because this is really important in plant design later on. Okay, and also I'm speeding through my videos now because I noticed that they're getting too long, and I hope you would still understand. If you don't understand what I have solved, so please ask me in the comments below. And also, if you haven't subscribed yet, please do so, so that it's really a big thing for this channel for me to survive. And running this channel alone now, and yeah, I'm doing this for my fellow reviewers also. And if you, as I said, if you don't understand what I have solved, please ask me in the comments below. Okay, so let's begin with our new lesson. Okay, so yeah, so this is my new logo. So I don't know if you've noticed it, because I've been putting this in my videos for a while now. So I will explain this way when we get to uh, distillation. Distillation, because distillation is one of my favorite subjects in unit operations. Okay, so now let's move on. So the absolute pressure exerted by water uh, 2 meters below the surface, okay, the swimming pool is this just a simple na rho GH, diba? So simple rho GH, so rho GH plus the absolute uh, absolute pressure, diba? So you have 1000, which is the density, yan. Okay, so plus 101,325, you will get 121 kPa. So this is in pascals this is also in pascals. So answer is letter B. So number 2, so please pause the video and then read the one and then solve it on your own. So now I will if you don't get the answer, let's solve this together. So the drawing of that is here. Okay, so kana siya. And then how do you solve this is you have to have the force balance. Okay, so A, kining water, kining mercury, kining water, and then letter B. Okay, so yan. So you have PA plus the density of water, and then we have specific gravity HM HI equal to rho HG G over GC. We have HM sine theta, so H2O, so that's density of water, D or GC 4 plus H1 plus PB. So let's move this to the other side, this term to the other side. So we will have PA, and then let's simplify everything. So we have H2O, G over GC, HM sine theta plus H2O, G over GC, 4 minus HM. Okay, so G over GC can actually be cancelled because it's just 32 over 32. 32.2 over 32.32 is 1. Diba? So we have PA. Then PB, we have 6, diba? 6 PSI. So 6 PSI, and then to convert that to PSF, pounds per square foot, just multiply that by 144. And then we have the density of mercury. HG din siya. HG. 848.6. And then 148.6 times the height, 5 over 12. So that's in feet na. So sine 15 degrees. Then plus the density of water, 62.4. And then we have 4 minus HM. So HM sine, I don't know, 5 over 12 sine 15 degrees. Okay, so solve for PA. You have 1198.4 PSF, pounds per square foot. Okay, and naging siya sa tuwa nga if PA was increased by 2 PSI. So let's add that by 2 with 2 PSI. Unang i-convert to daan, and then we have 1486.389. So this is in PSF, and then pull substitute that back in this equation kini, so that you will get the HM na bag-o. Okay, so that 1486.389, then 6144 plus 848.6. Dayon we have HM and U. Dayon sine 15 degrees ihapon plus 62.4, 4 minus sine 15. Okay, HM sine 15, and then you will get the new let's name this R, so that you will not be confused. Yeah. Okay, so R is now 1.83 feet or 21.98 inches. Okay, so that's it. So that's the answer. Okay, so let's move on to number 3. Water enters at 20 degrees Celsius. So just read that in your, and just pause this video, and then I will, if you get this on your own, and if you don't get it, just follow me in this solution. Okay, yan. So this is the diagram of that. So let's convert this to convert that to cubic feet per second, so that will be easier for us. Okay, 6684 cubic feet per second, and then we get the velocity at this point. So just divided by the diameter. This is 1 inch, diba? 1 inch ang diameter, ana. So 12 that's 12.25 feet per second, and then also there is sa ubos. Yes, in the second point we have 49.02 cubic feet per second. Okay, so now what is really important in this problem is the overall material balance equation, material mechanical energy balance, so OMEB. So OMEB, overall mechanical energy balance. So yeah, we have the shaft work, and then we have the change in potential energy, and then also in kinetic energy, in pressure, and also the friction. Okay, the overall, and then we're asked by this, di ba muna yung pangita sa tuwa friction, and we have no shaft work because we have no pumps. Yeah, we have no moving parts, we have no turbines, we have no compressors. Okay, yan. So let's move this to the other side of the equation. So we now have negative G over GC. G over GC, here is just 1. Okay, because they are the same value. Anong nangyari? Okay, so we have a negative V squared over 2GC minus P, and yan. Okay, so this is just Z2, diba? Z2 minus Z1, V2 minus V1, and then P2 minus P1. Okay, that's just that. Okay, so that's the now. Okay, so now let's take a reference point. So reference point I would like to use is here, kini. So this is the reference point. Yan. So kung muna siya tong reference point, so meaning ang Z2 is 0, di ba? Z2 is 0, so Z1 minus Z1 is 40. Di ba? 40 minus V2 minus V1, V2 is 49.02 squared minus 12.25 squared over 2 times GC. So 1.74 minus P2. P2 is 14.7 psia, di ba? 14.7 psia minus 24.7 psia. 24.7 psia, and let's convert that to feet. So pounds per square foot. So multiply lang by 144, and then divide that by the di ba? The density of the fluid, which is the water, so 62.4, and then you will get F now is 28.1 feet foot-pound force per pound mass. Okay, so foot-pound force per pound mass. That's it. That's the answer to our problem, which is letter C. Which of the following is not true? The answer this is letter D. So the power loss due to friction in a venturi meter is greater than in an orifice meter. So just compare. So compare para sa inyong Paris. So due to friction in a venturi meter, so tanaw ninyo, just see this is an orifice meter. So forgive my drawing. So that's an orifice meter, and then this is a venturi meter. Venturi meter. Ay. Yan. Okay. So as you can see, kung mo travel ang fluid diri, dako ka siya urag there's really a big impedance. So just imagine, no. So there is a big friction loss here than in here, because this experiences a sudden contraction, ba? This experiences a sudden contraction, whereas this is just a gradual. So I don't know how to really explain it, but that is the answer. Okay, so if you don't know, If you want to ask me, just ask me in the comments below. Okay? Next, pump delivers 40 GPM of water with a total head of 40 feet. So the efficiency of the pump is 65%. What is its BHP? So number 5. So let's check this figure. Okay? So we have a 40 GPM, 40 feet nga head. Efficiency is 65%. Okay? So we have 40 total head of 40, then galon 40 GPM. Okay? Yan. I figured this is the nearest figure in the Paris that we can check so that we will have an answer. Okay? So, as you can see, this is the 40, diba? 40 head and 40 GPM. Okay, and this I don't know how to really we have the BHP here. We have 1 HP, 2 HP, 3 HP, and 5 HP, which stands for horsepower. Okay, and we have two values that are below 1. Okay, I don't know if this is in the 7th edition, but the answer here is 0.62. Okay, 0.62 ang answer na. And this is also the answer in the reviewer. Okay, so for number 6, this is just this is really simple. So fluid flowing at that this is really simple. Just a Q. We are asked for the average velocity, which is Q over the Q, which is the volumetric flow rate over the area. No? Yan. So we have a 25 cubic meter and then 60 millimeters. So ba 60 millimeters nga kuan diameter na pipe, and then convert hour to seconds. You will get 2.5 meters per second. 30. Okay, so number 7. So turbulent flow generally occurs for cases involving very viscous fluid. No, this is for laminar. Very narrow passages or capillary tubes. Actually ang mga flow assumed there is laminar. Also very slow motions, this is laminar, so none of this. So number 8, so rectangular duct 4 meters by 5 meters cross section carries a conditioned air. So its hydraulic diameter is, so you have this in your Paris 4. You have the cross section area and the over the wetted perimeter. So we have just 4 then 1.5 meters, diba? So 4 cross section area is the 4 times 1.5, diba? And then the wetted perimeter, the perimeter of that, so 2 times 4 plus 2 times 1.5, ay 1.5, that's 2.18 meters. 30. Okay. Number 9. So we have a windy when the internal diameter of the inside diameter of the pipe through which the fluid flows is doubled, the pressure loss due to friction is per unit length of pipe, and for the same volumetric flow rate is changed by approximately a factor of yan. So how do we solve this? Just find the friction loss per unit length. Naani siya sa dyan ko, please. Yeah. FF is the fanning friction factor. Okay? So, and then you have the diba? The volumetric flow rate. Then it's just the dense area times the velocity of the fluid. And then if we transpose that, if we rearrange that, we have 4q over pi d squared. Yeah, so let's substitute that here. Okay, so we have 2 f l 4q d squared, then squared sa siya, g d. Yan, so p we have 32 FL Q squared GC D pi squared over D over 5. So if you can, as you can see, the relationship, so let's derive the relationship here. Relationship is negative P, diba? 1 over D to the 5th, diba? 1 over D to the 5th. So if we double the the diameter, so you will get kini siya, mahimo na siyang 132 d to the 5th, di ba? Yan. So this is letter C. Okay, so when number 10, if when two centrifugal pumps are connected in series, the discharge changes by a factor of. Yan. So if connected in series, so this is what I have shown you in the previous videos, di ba? Kung pumps in series gani, ang series, ang yahang volumetric flow rate ana is the same for the both, di ba? The same for the both. Kung parallel, it's just the sum of the two. The overall, it's just the sum of the two. So imagine you have an overall, diba? So ako na lang yung i-drawing para imagine ninyo. So same ra kung parallel. Kung series gani, kung parallel gani. So as you can see, the flow rate here is just the sum of this, and then the flow rate here is just the same for the both of that kuan sa duha ka pumps. Okay, so if centrifugal pumps are connected in series, discharge will be changes by a factor of, so it will not change man, so 1. Yeah? So kung kuan connected in parallel, number 11 connected in parallel, changes by 2. Ba? Anak na siya. So kaning for 12, so the pressure in a pipeline changes by a factor of when the velocity of fluid is doubled. So let's use the kini bitaw ini number 9, so number 9. So let's use that. So we have P, you have L there, and then if you have twice, yeah, and then you have 2V over D, diba? Is squared. Then you have 2V squared over D. So if you can see, this is everything cancels. Ang mabilin is 4. Yeah. So this is 4 pressure drop of the pipeline. Yan. So next we have number 13. So machines which need electricity to run are generators. They produce energy, right? So need electricity to run man. So they do not need electricity to run. Rather, they produce electricity. Yeah. So engines, no, not necessarily. Turbines, they produce electricity. So answer is motors. So number 14, cavitation occurs in a centrifugal pump when suction is lost. Yeah, suction is lost now. So Discharge pressure becomes too high, no. Discharge valve is closed, no, dili. There will be no flow. The suction pressure is too high, not necessarily. Yeah. Cavitation occurs when the pressure inside the pump goes below the saturated pressure or the vapor pressure. So mag-induce din siya og kaning low nga pressure, so meaning mag-boil then ang water nga naa sa pump. So that will damage your pump because if you can hear cavitation I've heard cavitation in our experiments, so it's really noisy. Okay? Yeah. So the required NPSH of a pump is specified to be 8 feet. Okay? Allowable vertical distance above or below. So we have to determine that, and then we are given the temperature and then the F. So kini nga F. Sigma F. Okay? Yeah. So let's go to the solution. The NPSHR, so the required na NPSH, so net positive suction head, NPSHR is 8 feet. So there are equations available in the Paris to get the NPSHA, so net positive suction head available. Okay? So we have mag-add ka og 5 feet or mag multiply ka og 1.35 feet. So equation 10-58 and 10-59, pili lang. Okay, and choose which of the formula produces much larger na NPSHA. In this case, if you add 5 to this, it will become 13, and if you multiply the 2 by 1.35, it is less than 13. Okay, so let's choose the bigger number. Okay, NPSHA. So NPSHA is NPSHR 5 feet. Okay, so that's 8 plus 5, we have 13. If you multiply 8 by 1.35, it's less than 13. So choose the larger number. Okay, so the temperature, diba, temperature nito is 25 degrees Celsius. So we can get the vapor pressure of water at that to be 0.4598 psi. So we can get this at table 2-5 sa Paris gihapon ninyo. So ang gibutang dito units is PMPA. So I converted that to PSA. PSIA. PSIA. So now we will get the NPSH. NPSH. No, we will get the Z, the delta Z. Okay, delta Z. So the formula for this is NPSHA. You have P1 minus P vapor pressure of the water divided by the density, and then we have Z, Z, G over GC. So that's just 1, and then the change in kinetic energy, and then we have the F, diba? So we have this, so we don't have a change in kinetic energy because it's assumed that the velocity is constant throughout. So we have 4598, then 144. So convert that to feet. Then plus Z minus diba 3.8 man to atong F. So and then we have 13 here. So Z is actually negative 0.06 feet. So this is below. So below siya. So ato ang gi-assume nga assume nga reference point which is above. Okay, 16 feet A. Okay, so 16 is just a simple the 16. Okay, so mo din siya. Wala na ko napakita. Wala na napakita ang kining drawing, but here it is. Okay, so let's just clear all the ink and slides. So nga na siya, and then kato din ganina do that. So muna siya. Okay, so let's move on to number 16. So this is just solving for Reynolds number. So Reynolds number is magtanim ay dv rho over mu. So we are asked kining laminar daw siya. So the number is laminar ang Reynolds number nga laminar ang flow is below 2100. So yeah. So we are asked for the velocity, diba? So for the velocity, so we have a 0.5. So I'm converting everything to feet. So 60 dayon 30, diba? So 60 ang 30 cp. So just multiply that by 6.72 times 10 to the negative 4 para ma-convert na siya to lbm over feet per second. 2100. Shift solve to find v. You have 16.9 feet per second. Yan. So you have letter D. Number 17. So I don't know how this is being solved. Actually, I don't know how to solve that. So just check F10-13. Okay? So F10-13, figure 10-13, and you will see the answer to that. So just kini siya nga number so that the maximum Reynolds number over the average, diba? And then you will get this. And also I saw this problem in Myrckho, which is really the exact number good. Exercise yan 2.6-3 in Myrckho, where you are asked to solve this equation. So this is, you have to integrate this actually, and I don't know how to integrate that. So yeah, and then you will get that the answer bitaw ana kay v max over v av is 60/49, which is 1.22. Coincidence kayo. I don't know how did they solve this. Okay, for number 18, so just read the and then if you just pause this video, and then if you don't know how to solve this, is that we'll solve this together. Okay, yeah. So this is the figure to that problem. Okay, so figure to that problem, and then we have points 1 and 2. Okay, so it's obvious that we have to work with the OMEB here, the overall mechanical energy balance equation, diba? G over GC 2GC plus friction. Okay, so as you can see, let's simplify. So diba horizontal raman ni siya, so 0. Okay, and then also 0 kay walay change in velocity and no change in elevation. Let's that makes our life simple. And then let's actually the point with the reference point ato is after, diba, after the pump. So meaning dili nato appeal, so the pump is not included in the calculation, so the shaft work is also 0. And so this makes our life easier. So, and also ang F, kini F. So F, di ba summation man ng F. So what this actually contains, di ba? So you have FL, which is the friction along the length of the pipe, and then we have FV, which is the fittings and valves, and then we have FC, sudden compression, and then a sudden contraction, then and sudden expansion. And as you notice, we don't have any of these. We only have the along the length of the pipe, and this is equal to 2FF, the friction factor, length of the pipe, times the velocity squared over GCD. Okay, so let's plug this into our equation. We have we are now left with delta P over rho, then 2 FFLV GC and D. Okay, so let's plug in what we know. We have 14.7 minus 20 psia. Convert that to PSF, and then 62.4 into FF 100 ang length sa feet. Dayon we have velocity squared over 32.174. Dayon the diameter of the pipe. So as you can see, we have 12.23077 43240 F then V. As you can see, as I've noticed, there are two unknown variables, diba? So unsa may ato ang strategy ani. So this is all these drawings that I'm showing you, they are from Sir Myrckho Miguel Mendoza. This is my teacher sa Quantum Review Center. So shout out to Sir Myrckho Miguel Mendoza. So he helped me solve these problems, and I'm really very grateful to him for help me solve these problems. Yeah. So this what is our strategy now? Okay. So he proposed this. So assume any value. Okay. So it's a I'll just read it to you because it is being blocked by my video. So assume any value. Ato na lang I will stop my video so I can read it to you. Okay. So assume any value of F and solve for V. Okay, solve for the Reynolds number and plot on the Moody chart to get F. Then solve friction factor should be approximately equal to Moody chart. If not, repeat 1 using Moody, and then when equal, take the velocity. So we are iteration bitaw. So this is really a difficult nga round, but I'll just give you a taste of it. Okay, so assume the friction factor is 0.0030. Okay, and then if you plug that in here, so you will get V is equal to 18.10876 feet per second. Kung mo na siyang i-multiply, i-quandary. So, NRE. So, solve for the NRE. So, you have the diameter, and then just assume so we have, ako na lang i-solve. So, d0. So, 6/12. Velocity is 18.10876. Dayon the density is 62.4. Dayon you have 1 cp. So just assume 1 cp nga viscosity, and then you will get 8.407 times 10 to the 5th na kuan and re. And then from Moody chart, actually if you if you plot this against the Moody chart, you will get FF is equal to close you guys sa 0.03. I'm cheating, but this is the fast version of that. So knowing that this is equal, so you can find now the volumetric flow rate, diba? Which is this, and then you know all of that, then you will get this 3.556 cubic feet per second. Yeah. So this is 3.58. So that's letter D. Okay. Now let's go to number 19. Number 19. So storage tank. So please read that na lang. And then if you don't know how to answer that, this is the solution of that. 19. So cost is equal to 3.5 HP 0.746 HP. We have 12 hours a day, and then we have 3.73 pesos per kilowatt hour. Then we have 300 days per month. So cancel. You will get 5,086 per month. Yeah. So there B. Okay. So when the impeller speed by the centrifugal pump is doubled, the volumetric flow rate of the discharge is increased by a factor of. So number 20. Just look at the infinity loss. So that's table 10-13. So you can see this there. So constant constant. Constant. You'll find this there. And then if you double the speed, diba? So you will get Q2. So just let's just sa tawag na kaning reciprocate, diba? So you have N 2N1 over N1. You will get 2, diba? 2Q1. So rate discharge is increased by a factor of 2. Okay. So number 21, so differential height between 2 points where a fluid has to be transferred is D. Okay, so differential height. So kini, diba, differential height between 2 points. So kini, diba, this is the Z. So this is the potential head because this deals with potential energy. So next is the bursting pressure of a pipe is directly proportional to its schedule number, because schedule number has this formula, 1000 over P. PS is the maximum pressure over the safe working pressure. Safe working. So stress dito niya na. Mag-safe na niya nga stress. Yan. And pressure and stress have have the same units, so they will cancel and then you will be left with the schedule number. Okay? So number 23, device for measuring differential pressure is manometer, potentiometer, ammeter, galvanometer, therefore electricity. Okay? So they will measure voltage, current, yan, and resistance. Number 24, NASA, the dimensional number that characterizes the flow of fluids in a conduit is, this is really recurring. So number, letter D, Reynolds number. No, number 25, when the fluid flows through a reducer in a piping system, the velocity at the outlet end is blank the velocity at the inlet. So reducer. So mag-reduce ang area, di ba? So meaning kini dire diha. So di ba kung pamisbis mo, if you are watering your plants using a garden hose, di ba? If you reduce the area of which the water will flow, the velocity of the water increases, di ba? So meaning it is more than na at the outlet man. So V2 is V1, so V2 is greater than V1 based on experience. Number 26, at the given flow rate through an orifice meter, the differential pressure across the orifice will increase when. So let's draw an orifice meter here. So this is an orifice meter. I haven't seen one in the plant, but this is what looks like in the drawings. So yeah, you have a manometer here. Then this is filled with the manometer fluid. May it be a water or mercury, I don't know. So the pressure across the orifice will increase when. So it will increase when the orifice flow area is decreased. So density of the flowing fluid is decreased, or orifice flow area is increased, or the thickness of the orifice is decreased. So imagine if you orifice flow area, if you decrease this, will increase man. So differential, so kinanglan nga magdako ni siya, kini the difference, di ba? Let's zoom that. So dako ni siya, we will maximize this differential nga kini siya. So muna siya, di ba? So if you decrease the flow area, so pagamian pag nimo siya, so meaning ang flow ana mugamay gid siya, nga mugamay hangtod nga ahe pa rin siya mudako, mudako ni siya na muna siya nga kay tabo sa orifice meter. So if this decrease will decrease, so the imagine ng tubig, okay, imagine ng tubig, it will not fill up this. So meaning ang pressure ani nga side is lower, di ba, because there are less nga water nga manhid diri. So less water that will push on the manometer fluid here. So more water will push here, so meaning mudako ni siya, mugamay ni siya, mugamay, then mudako, okay, because gamay raman ang pressure diri nga area, and then dako kay ang pressure diri nga area. Okay, so this is the big larger pressure and then lower pressure, so meaning that's how it is, differential pressure will increase, okay, because the height is increased. So that's letter A. Okay, number 27, the prime mover of jet pump is an. So syempre if you have this jet pump, so I haven't seen a jet pump, but it doesn't use electricity. Yeah. Okay. So the answer this is fluid momentum. I don't know. The answer is fluid momentum, not a motor, not turbine, not engine. Okay. So number 28. So we have the weight rate. So weight rate. Flow fluid system per unit across section perpendicular to the direction of flow is pangitaan na lang ninyo ang asa ang weight dara. So mean linear, no, velocity head, no. So mean mass, so mass, then weight, so they are interrelated. So number 28 is letter D. So 29, the ratio of the quantity of the liquid is actually pumped to the Okay, to the piston displacement is called volumetric efficiency. Quantity of the liquid actually pumped then corresponds to the piston displacement. So in that volumetric efficiency na siya. Quantity of liquid man. Yeah. So number 30, so the schedule number 5 is an indicator of the pipe's thickness. Yeah. So if you will check the Paris table 10-22, so you'll find it there. It is really a function of thickness. Muna siyang the schedule number. So the greater the schedule number, the thicker the pipe. Yan. So number 31, so higher the BWG. BWG is Bingham wire gauge rating. This is used in heat exchangers. So gagmay ni siya nga mga tubes. Okay? So they are useful to that function. The lower, so the higher the BWG rating of a tube is, the lower is the 31 is the strength. Okay? So because the higher the BWG rating, so magkagamay ang diameter, the lower, the higher the BWG rating, the lesser or the diameter. Okay, so if the diameter is lessened, so it will be the strength is reduced. Okay, so number 32, so inside surface of pipe has no effect on the friction factor when the flow is turbulent. Surface of pipe, so this is not really a I don't know study. It is studied, but the nature of the turbulent flow is chaotic and it is not orderly. As you can see in the undergrad, so we are used to see this, diba? So muna siya sa laminar, and then sa turbulent flow kay kuan is really chaotic. So the pipe, if the inside surface of the pipe does not really gamay kay siya, it's negligible lang yung effect kung turbulent ang flow. Kung rough kay ni siya, it will really have a big effect on the in the velocity ba sa pipe, sa water inside the pipe. And so number 33, so 33, movement of the gas vapor affected at low pressure. So low pressure, tandaan lang gid ninyo, you have to remember this. If it is low pressure, say 0.1 kilogram force per square centimeters, the equipment used is A. So this is blower daw. So blower, so movement of a gas vapor, so you have to assist it with a blower. Okay, and also if you have to move it with a larger, so meaning a larger force, so a larger pressure, so you have to use compressor. But if gamay lang, you have a blower. Yan. So 4-inch, so this is actually interesting, number 34. So you have the safe working fiber stress, so S, this is safe working stress, S. And then we have schedule 40, di ba? 40. So pangitan na to ang maximum steam pressure. So let's use the formula for the schedule number. So P then S. So P we know P S 457.1, and then we know schedule is 40, diba? So just shift solve to find P. You will get at 18.3 kilogram force per square centimeters. Yan. It's letter B. Okay. So last number is number 35 for this video. So a rotameter. So yan. Just read that. And then the way to solve this is we have CCl₄ and then we have H2O. We have this formula, Cl₄ times the density of the water. Then kaning S is the steel nga ball. Ang steel nga ball. Then CCl₄. Density of the CCl₄. So density of the carbon tetrachloride is 1590, and then we know the volumetric flow rate of water will be 3 cubic meters per minute, and then you have just substitute, di ba? 8,000 man ang density sa steel, rotate, and then we have 1,000. Just assume it is 1,000. Then we have 8,000 minus 1,000. Ngayon, we have 1,590. Then you will get 2.3 cubic meters per minute. Okay, so that's letter C. Okay, so that ends our video. So I hope it is really a short lang na video. So this is not a really a long video that I have made. So maybe mga less than 1 hour lang. unta. Okay, so I'll see you on the next part. Okay, which we will solve the last 20 problems. Okay, because this 55 items. Okay, so that's it. Bye.